Hello everybody, my name is Rodolfo Miranda from Roots ID. This is the final report for the project DIDComm V2 Mediator. It was on the challenge Self-Sovereign Identity on Fund 8 with a budget of a little more than 20,000 US dollars. Roots ID team is composed by Lance, Esteban, Butch and myself. Here at Roots ID we're an open source development team that builds self-sovereign identity components on top of Cardano and mostly on top of Atala Prism. Atala Prism is the identity solution from input-output. Our main product is Roots Wallet. That is an identity wallet that helps you store your credential, personal information and communicate with others and sharing that information. A complete ecosystem also requires other components such as cloud agents, resolvers and Mediator, and this one is what we're going to talk today. For this project we really pick a really technical name, DIDComm V2 Mediator, so I'm going to try to explain what that means and why it's important in a self-sovereign identity ecosystem. Here you see two identity wallets. We call self-sovereign identity wallets because you have control of all your identity. You store there private information in a format that is called verified credentials, that are kind of certificates that prove something of your identity, like a birth certificate, can be a driver license, or can also be a diploma from some training that you already passed. Now that you have these credentials on your wallet, in order to use it for some goal, you need to pass it to the other user. But because it is private information, this communication needs to be really secure. You cannot rely on internet because internet is not secure. And that's when DIDComm V2 is needed. DIDComm version 2 is because it's the latest version. Is an open standard built by DIF, that is the Decentralized Identity Foundation. It's a working group that everybody is collaborating and adopting. We as Roots ID really contribute to the approval of that version and to some guidebooks. The protocol is really secured, private, have several features, like you can send messages in a reputable way. That means that is kind of sending a secret that the receiver can receive the secrets, can validate that it came from me, for example, but he cannot tell and prove everybody that he has a message from myself. So this is reputable. Non-reputable is the opposite, is I can send a message, the other party can receive, validate that came from me, but he can also prove to everybody that that message belongs to me. Having our wallet in a mobile device is really handy because we can use it everywhere. But being everywhere is a challenge for the technology, because when you jump from one internet connection, for example from your Wi-Fi in your house to your car, when you get internet from your mobile provider, and then you go to another SSI, you are changing this IP, you are changing the endpoint. So you cannot, as a application, as a mobile application, provide a unique endpoint for anybody to contact you. So how we solve that? Normally, all the application like Discord, WhatsApp, Telegram has a central agent that is on the cloud, so that used to pass messages from one user to the other. That's the way it's already solved. But this is centralized, so this is a nation that has control of everything, and it's don't really match with what the SSI is looking for. So how we solve that? This is really challenging. We solve that by what we call a mediator. That's going to be a relay agent, still be a centralized agent, but he cannot decode the message. The message is still encrypted, so they cannot see the message. He cannot even know who is the sender of the message. It's open standard, and that means that there is no vendor locking, so it can be my mediator, can be anybody mediator. You can select and move from one mediator to the other, and that's the way we're trying to solve the issue of not being centralized, as we call that. It's not vendor locker, and actually you can move from one mediator to the other. It's based on a DIDComm protocol. That is something that is built on DIDComm, on an upper layer of DIDComm, and how it works is that someone send a message. It works like a post office. So someone send a message to the post, and then the other person go and retrieve the messages that are pending for delivery. So now, what we had to do in this project. First of all, we had to define this protocol that is called the Mediator protocol. So that we work that in DIDComm working group. If we go to the web page, DIDComm.org, as you see here, you can browse for protocols, and there are actually two protocols that was involved in this for this project. One is called the Mediator Coordinator. You're gonna see this is something that we need to submit, push request, share with other members, collaborating and improving the protocol. This is what we actually then we implement it, but we need to be approved. And there's another protocol that is called Pickup. I think this is version 1, but we need version 2. You're gonna see my name here. So this is the protocol, Pickup version 3. So this one is also the one we proposed and was approved. And you're gonna see all the details of the protocol that we actually implement in our mediator. The next step, the most important one, is to actually develop the mediator. You can find all the code in our repo in GitHub. This is Roots ID, DIDComm, Mediator. So the code also has in the README the instruction to install it, to deploy it, the dependencies on the MongoDB, some configuration parameters, and to actually run it. And you can also, there are instructions to provide a Docker hub to deploy everywhere in the cloud. The next step, number 3, is to test the mediator. For that, we provide a proof of concept in our Roots wallet. They are really simple proof of concept, no UI, UX. So you're gonna see that in the next demo. And there we show how two wallets communicate through the mediator, sending just a simple message from one to the other and retrieving the message from the mediator. Okay, you can see here on the left Alice mobile phone, on the right Bob mobile phone. The first step is communicating with the mediator and creating a DID that's going to be needed and passed to Bob. In this case, it's a copy and paste, but in an actual real environment, it's going to be like a QR code. Bob does the same, connect with the mediator, request mediate, and create a DID that's going to need to pass to Alice. Now here he's going to paste Alice DID. Reminder, that's going to be a QR code in the future. And now copy and paste Bob's DID into Alice wallet. That way both wallets can communicate through the mediator. Now what you're going to do is check for messages. You're going to see there is no messages, and send a message to Alice. Say, hello Alice. Send a message, and now Alice can check the messages pending on the mediator and retrieve it. And same to the other side. Same response, and Bob check for messages and retrieve it. Then we also provide some documentation and a tutorial to use the mediator. So that can be also as a learning experience for others to adopt the Mediator. So also in our repo, there's a full explanation how the protocol works. I think it's here. It's here, but we also provide a folder with some Jupyter notebooks. This is Python notebooks that you can actually test it. If you go to sample notebooks, you're gonna find Alice and Bob. That is kind of similar to what we did in the Roots wallet, but implemented here as a code that you can run and test in step by step, and actually do the same that you see on the Roots wallet by yourself. Finally, as was expected on the proposal, we host an instance of the Mediator in Amazon Web Services. So it's free to use. It's, the project paid for 1 year of hosting, and actually it's probably not used for commercial, but it's really nice for prototyping and learning. So if you go to our repo, you're gonna find these QR codes, also these simple QR codes that can be used to start the conversation with the Mediator. And now that we have this Mediator in the cloud, we also extended to provide more protocols. It was really easy because it was developed to be extensible. We provide other DIDComm protocol like Trust Ping, Discover Features, a basic message, WakiPex, that is a way to share credentials, short-term URLs, that is how we move from this big URL to this smaller one, action menu, question answer, and we even did a Atala Prism issuer that I'm gonna use in another project. So as a conclusion, what we achieved, we help standardize DIDComm v2 protocol. We developed this open source Mediator code so everybody can share, and we host it in an instant in the cloud, so it's ready to be used to everybody. And with that, we think we really contribute to the global SSI community, and that was thanks to Catalyst. And in the name of the full team of Roots ID, we really want to thank you for all the support and opportunities you gave to us to work in what we really love. Thank you.